How y'all? We're gonna talk a little bit about some chromatography that we're gonna do. And you know, I know that y'all have experienced this before. You know what paper towels are used for. They're used for like sucking up liquids, right? Mopping up spills. So guess what? This is gonna be really exciting, but we're gonna essentially do what amounts to a piece of paper. And here I'm gonna do this in front of you. I hope it works. But you're gonna dip it in water, and when you dip into water, you see how it's climbing up there like that? Now you're thinking, oh wow, that's really fun and exciting. Well, yes indeed, it will be fun and exciting. We're gonna use this principle right here and perform a chromatographic method. All right, so I'm gonna move to the board here. We're actually gonna change this into chemistry application. The theme is chromatography. Not going to go into the history of it too much, but it had to deal with when they first discovered it. It was all about separating out plant pigments, and hence the word chrome in this. Fundamentally speaking, what's going to happen in chromatography, no matter what kind of chromatography it is? Chromatography, you need to think of it as it's a separation technique. And when you separate these things in your mixture, you can identify what these individual components are, and you can also quantify like how much of that component is in there. And when you do chromatography, there's two concepts that are involved. There's something I'm going to refer to as the mobile phase and something called a stationary phase. So there's two phases. What does mobile phase mean? It's literally moving. And the stationary phase is literally stationary. It's not moving. So pretty much every form of chromatography will have these two things occurring. It's just going to be a matter of what kind of material you use for the mobile phase versus the stationary phase. All right, now what we're going to do in the chromatography lab is our mobile phase is actually going to be a liquid. You saw the liquid climbing up the paper towel. So the liquid's going to be the mobile phase. And we're going to do a couple different kinds of liquids to see what kind of impact the liquid has on the overall process. The stationary phase of what we're going to do is literally going to be some chromatography paper. It's not going to be some simple little piece of paper towel. It's actually kind of think of it as like photocopying paper, except it's got kind of like a rough texture to it, and it's really good about drawing the liquid up the piece of paper. So kind of as a little quick observation of what this is going to look like, you're going to have this beaker, and you're going to have just a little bit of liquid in here. And they're going to take this piece of chromatography paper, and let's just imagine that the paper is just sitting in the liquid like this. Well, with the paper towel, you saw the liquid climbing up the piece of paper. So what we're going to do is we're basically going to, I don't know, you can almost think of it as like a marathon or something like that. You got a starting point, and we're going to end up drawing a starting line. And we're going to put little small amounts of sample right on that starting line right there. And when you put the paper in there, we've already seen how that liquid is going to start climbing up the piece of paper. Now when I put little small amounts of sample on this little starting line, I mean, I don't know, ask yourself, what do you think these little components are going to do as this liquid is climbing up the paper? All right, I'm not going to tell you. We're going to observe what's going to happen with that right there. And what we're going to hope that's going to happen is that when we put mixtures, I mean, some of our components are going to be mixtures. And when we put mixtures on there, they're going to separate. The components in the mixture are going to separate from each other. And I mean, I kind of feel remiss that, I mean, I have to refer back to first semester chemistry and you really got to talk about intermolecular forces of attraction. I mean, you have a piece of paper, it's made up of cellulose, more or less, cellulose molecules, and then you're going to have some sort of liquid basically flowing along the paper, and it's, it has some sort of intermolecular force. And the paper has some sort of, I'm just going to call it IMF, okay? So when I have a sample on this piece of paper right here, the sample that you've got, it kind of has like a choice. It's going to have an attraction for the paper, and this sample is going to have an attraction for the liquid that you've got, which, by the way, this liquid is flowing along the piece of paper. So what is this sample going to do? Is it going to stick to the paper? Is it going to flow with the liquid? And that's what we're going to kind of find out when we do this chromatography, okay? Kind of actually even looking at the intermolecular forces of attraction. All right, I'm going to go ahead and pause the video right here. We're going to start up another video, and we're going to actually talk about some measurements that we're going to make in this chromatography lab.